Okay, this is Geometry Review 3. We're going to discuss solid geometry, solids. Okay, so we'll begin with the cube. Yeah. Let's see if I've got a good cube shape. No, nothing. Let me try this one. Okay, so we got a cube in front of us. Yeah. And let's just say that this cube has a volume of side cube. Yeah. And the area is, it has 6 surfaces. So it'll be 6 times side square. That's the surface area. Surface area. Okay. And if the dimension of the cube is, let's say, 3 centimeters, yes, then the body diagonal is from this corner to this corner out here. So this blue dotted line would be the body diagonal. Yeah. So it's top right corner to the bottom left corner. So imagine you're in a square room. Yeah. So that room has walls and floor and ceiling. So the longest diagonal of that room would be from one corner, yeah, to the other diagonal corner at the bottom. So we can say one corner on the top, yeah, diagonally, if you follow that to the bottom corner, that is the body diagonal. And therefore the body diagonal is root 3 times side. That is the formula for the body diagonal. Okay. Moving on to the cuboid. Cuboid, also known as rectangular prism. Okay. So this is what you would say a rectangular prism would look like. Okay. Yeah. And then you have a dotted line, which is inside like this. So, so these 3D figures drawn on a 2D plane kind of looks complicated because it might look like it is sleeping, like it is shaped horizontally, where the biggest surface area is flat on the surface. It might look like that, but I've drawn it where the smallest surface that you see is standing up, right? So this portion is on the top, I would say. Yeah. And consider this as a building, and you'll be able to understand the shape which I've drawn. Yeah. Okay. So this is what I want it to look like this. Got it? So therefore, when the drawings are too perfect, it kind of blurs the uh, thought process, whether it is standing upright. So this is upright, right? Imagine these are, the windows of the building. So this is a cuboid, okay, where you have the height, where you have the length, and you have the width out here. All right. So therefore, the volume of a cuboid is length into width into height, and the surface area is twice the length into width plus twice the length into height plus it would be twice the width into height. Okay, so this portion twice width into height is obviously the red portion out here. Yeah, twice length into height is obviously the window portion. Yeah, that one. And the twice length into width is obviously the terrace, you would say, the terrace of the building. Yeah. So this one also has a body diagonal from here to the corner out here, and therefore the body diagonal out here body diagonal is equal to root of the length square plus the width square plus the height square. Okay. Now in the previous shot, it's a cube. So in the cube, all sides are equal, and therefore the body diagonal is root of s square plus s square plus s square, which is root of 3s square, and therefore it is root 3 times the side. That one. Okay. So that's about the cuboid. Yeah. And I would love to give questions out here based on cubes and cuboids, but then we have a review of questions where I've discussed cube and cuboid questions as well. So I'm just giving you a brief overview of the solids out here, and I'm not discussing any questions right now in this particular video. Right, moving on to the cylinder. Okay, so I'm discussing commonly asked solids. So cylinder obviously is also known as a canister, right? Now, obviously, this is for the UGC, yeah, CSIRNET. So they won't use the word canister, but you never know. Okay, so just learn these words. Canister is cylinder, yeah, and the volume of the cylinder is base area into height. So the base area is pi r square because it's a circular area, and then into the height. This is your height from here to, here. So that's it. That's your height. Yeah. Surface area. So we are discussing the total surface area, right? So total surface area includes the two bases, so 2 times pi r square, correct? And if you have a can, for example, I would discuss the Indian, cans where you have those rasgullas and gulab jamuns in it, and then you have a wrapper around it. So the wrapper around it is the circular surface area that we're discussing out here. So with the base 2 pi r square and the wrapper around would be 2 pi r. It is circumference into the height. Yeah, so that's your total surface area. That's the wrapper part without the top and the bottom. Okay, so circular surface area plus the uh, you know the circles together is the total surface area. So that's it about the cylinder. Yeah. And then we move on to cone. So cone, now you'll also probably not, you'll also probably hear right circular cone, right circular cylinder. It just means where the tip, yeah, it just means that the height is perpendicular to the base, and with and in the right circular cone, the top, that is the tip of the cone, coincides with the center of the base. So right circular cone, remember these words, it just means a regular upright cone, regular upright cylinder. So out here, the volume is 1/3 the base area. Always, whenever it is pointed, remember it'll be 1/3 the base area into the height, which is 1/3 base area is pi r square into the height. Now out here also we have a total surface area, which is basically the base pi r square plus this basically the cap part, which is pi r L, where L part is this. This is the slant length is called your L. Slant length is called your L, pi r L. So imagine you're making a hollow cap, the clown's cap or the party cap that you have. So that area of the cap is the pi r L part. Yeah, and this is the base area, circular area. Moving on, we have the sphere, and out here we'll discuss the hemisphere as well. So we have the hemisphere as well, which I'll probably write down here. So hemisphere is like a dome-shaped structure, and a sphere is a ball, basically. Yeah. So the volume of a sphere is 4/3 pi r cube. The surface area out here is 4 pi r square. That's it about the sphere. And the hemisphere, now this is, you need to think. Yeah, you need to think. What will be the volume? Volume will be, basically, it's half of the sphere. So it'll be 2/3 pi r cube. Yes. And the surface area is quite interesting. It will be half of the 4 pi r square, so 2 pi r square, plus the base area, which is pi r square. And therefore, you get 3 pi r square as the surface area. Okay. So one last thing before we move on is the pyramid. So I'll probably just put the pyramid out here. Yeah. So we have a pyramid, yeah, which is a four-sided triangular figure. So you have, a square base. Yes, a square base. Okay. And you have side 1, side 2, side 3, and side 4. So and you have a square base. So this square base is this is the square base. So out here for a pyramid, you will be saying the volume is 1/3 the base area into the height. So out here it'll be 1/3 if it's having a square base or rectangular base. So usually it's a square base. So 1/3 the base area is side square and the height. All right. So it just depends upon what kind of base you have. Okay. And it'll be 1/3. It'll be pointed. Anything pointed will be 1/3. So that's the short review on solids. Yeah. And my next video, we'll discuss a few questions which are there in my the worksheet which I've created for the geometry review. And we'll discuss if not enough questions are discussed on hemisphere, sphere, pyramid, or anything like that. I'll add some questions while discussing the geometry review 4. So that's it. Thank you. Yeah, stay tuned. That's all I can say. Thank you.